All right, it's on. So thank you all for joining. This session is for the Navigators Final Milestone Check by the zkNoid team for the Elven Lottery. So over to you, Andre, Alex, and team.
Yeah, thanks, Harish, for introducing. So my name is Andrei. I'm building on zkNoid. We are a gaming platform with provable games. So today we're gonna talk about our navigators proposal that we finished and delivered the milestones. So let's check them. Uh, uh, we wanted to create a game that can be played on mainnet. We all was amazed with the Berkeley update of Mina, and we wanted to try the real product on the network, to make transactions, to interact with the network. So the simplest game we imagined was a lottery game. In this game, you need to buy tickets, choose numbers of the tickets, and after a round, like 24 hours passed, a winning ticket is generated. And all the tickets in the round are distributed with the rewards based on pairs luck, how many numbers I guessed. So with this idea, we created a navigator proposal, and we submitted the following milestones for our game. We divided the product on four parts. First of all, Contracts is a blockchain site that implements all the on-chain logic, such as transactions for buying tickets, producing results, receiving rewards. Such mechanism as fee receiving, refunds, and tests for the contracts. We wanted to make a convenient design because the K is not so user-friendly. It has a lot of off-chain data, a lot of synchronizations, and we wanted to prototype a design that can be user-friendly, that contains all the logic we wanted to add to lottery, and still it should be very intuitive for players. We this is about design side. For the project, we needed a backend. It should contain workers to create proofs in background, to sync data from archive node, to implement some background logic to to produce some data for players like claim proofs. We proposed to create a backend site. Also, front end is like the implementation of design the user interacts with. It should be connected with blockchain, with backend, and all the stuff. This was the milestones we proposed. Let's During the navigator's journey, we implemented all the milestones we proposed. Let's review how we came to our final solution. First, we implemented functions to buy tickets, to produce some result, and to get rewards. We faced some challenges because we all the functions update Merkle trees, and it's hard to make concurrency of functions calling, because when you buy two tickets in one block, the transactions may be ordered in a random way, and they can be placed incorrectly. So one transaction will fail and second will pass. So to fix the concurrency issues, we implemented a reduce. We used a reducer. We implemented reduce proof and used it to allow concurrency, to allow to buy tickets concurrently. We also faced some challenges like issue with concurrent actions production in block, if there are more than 3 actions, we have a failed fetch actions function. So this was we had a big and hard journey to implement the contracts to make it strong and prevent from failures. The next part is design. We faced the challenge to combine all the logic we wanted to see to a one-page application to give user one page where all the logic can be accessed. So we implemented all the states, all the interactivity things. We implemented views to see current round, previous round, to see tickets history. So we accomplished all the things we wanted to see. Also, we implemented design for access codes to allow to gift a ticket to a friend. So you can buy a ticket, give access code to a friend, and friend will receive the ticket. So we implemented all the things in design, and some additional things we haven't mentioned in proposal as well. Next challenge was to implement backend and front end. First of all, we implemented workers to generate some proofs in background, like distribution and reduce proofs. We implemented synchronization with zkNoid, so events are fetched when they come to the network, and we don't need to refetch all the events from zkNoid, only the new events. We implemented the win tickets producing, so when round ends, the result is automatically pushed to the lottery game. We implemented all the transactions proven in sending. We faced the challenge here because first we fetched all the data from front end, and we noticed that it's too hard for user to fetch all the data, process it, and use, and we moved to some logic to backend. So now round events are synced on backend, and only the prepared information for user is sent to the front end. This greatly reduced the speed of page loading, and we accomplished a great user experience. So now we have a working front end that's connected with backend blockchain, and it allows user to completely interact with all the logic we proposed to implement. We have ambitious plans, so we was waiting for the Keon to be ready for VRF integration. Now they are ready, and we'll integrate their solution soon. Then we want to implement transaction reordering. So as I mentioned, we used reducer in tickets buying, but reducers can't be used with nullifiers. So we are implementing a custom solution for claims to be executed in the same blocks. It's transactions reordering feature. So we're going to allow multiple claims in the same block as well in future. Then we want to launch gift codes buying and using. It's designed but not implemented yet. Then we want to wait until the actions fetch issue is fixed by O1JS team, because it's a blocker for our project and can block the entire lottery game and other ZK apps. So we need to wait the fix. Then we're going to audit phase, and then we hope to be launched mainnet. So let's demonstrate how it looks like in reality. Just a moment. So here I I open the lottery game. So here we can see the status. We have the caps require cache loading. Now the cache for the caps is downloading. When it's finished, we'll wait for the ZK app compilation. After compilation, we can use the application. It took a little to download it. Now reduce contract is compiling, distribution contract is compiling. Finally, our ZK app is compiling. So in this short time, we have the application compiled, and we made a lot of optimizations to make it so short. Here on the page, we can see current routing for the timer, the bank, and here is the sections with my tickets. I already bought this ticket. Let's show how to buy a new one. Here is buy ticket section. I click new ticket. I can fill it myself. I can use randomizer. So here I submit ticket and pay. So we need to prove transaction because of this. We need to wait some time. All the transactions generated the key proof. Here is the transaction. You can see account update here. We have balance change. So we pay 10 mina for the ticket. I confirm the transaction and I can see the transaction status in my wallet. It's pending now. When it will be executed on blockchain, we'll see a new ticket here. Here, while transaction is executing, we can see the previous lotteries. We can see the previous outcome. So there was 3 rounds. In first round, I had these tickets. We can see the numbers of the tickets, the status claimed or allowed to claim. Some ticket has no funds because the numbers was guessed incorrectly. So we have a view for previous rounds. So here is round 1. We can see the winners. We can claim rewards. Just a moment. So on these views, we can see the history of the rounds. So let's see what's about the transaction. It's still pending. Block production is pretty slow on Mina. So let's try to claim some reward on the previously bought tickets. So I tap the claim button when I want to get my winnings. It takes also some time to generate a proof for the transaction.
And this is claiming for all the wins, right?
No, for just one ticket.
Okay.
It will implement features for claiming all the tickets, but it requires some off-chain logic and not yet implemented. Here we can see the claim transaction. We can see the balance change. It's the same as the winning that is described here. So we'll receive 45 mina for our winning. So it's also a transaction. We can see the transaction status here. When block is produced, we could see the balance change and the new ticket here. So we implemented working lottery that is very close to testnet. Actually, we after fixing the O1JS bug and integrating zkON Oracle, we wanted to launch mainnet or to launch testnet. I think on this week, and we'll invite the real players to test the lottery game. Block production is pretty slow on Mina, so it may take a lot of time until the transaction is executed. So I think that's the overview of our job made during the proposal implementation. So we implement illustrations and all the things to make the game as easy and as fun as possible for players. So I think that's all I want to show for today. I hope to make a lot of further games on Mina protocol. We're just pioneering the gaming, and I think we can implement a lot of more interesting things in future.
Awesome. Thank you very much, Andre. I do have a question. So currently, as many tickets are purchased, it goes into a pot, right? So if let's say one ticket is 1 mina and 100 people purchase, then the price pot is 100 mina. Is that correct? And are there any fees deducted or are anything charged by the platform
Yeah,
or Mhm.
our platform have a revenue system. We got 3% of ticket price as a service revenue. So yeah, we have a 3% fee.
Okay, thank you. Now I have one question which I think is maybe about the future. When you mentioned you could buy like codes, or like I could give you a code for a ticket and you could claim it. In this case, how do you manage the pot of that particular round? Because when I buy something, I'm like making an on-chain transaction to add it to it. But if
Yeah,
I
we wanted to implement off-chain logic for this.
Mhm.
So you receive a code, and then when friend use it, the backend is executing a transaction. So it will be managed by an off-chain logic.
Right. So there will be Mina deposited into like whatever your pot is as
Yeah, we'll have a contract that receives the payment for the ticket, and then backend will execute the transaction in background when it confirms the payment and use the code.
I can add to make it more clear. So when you buy a code, you're not buying a ticket, but you buying an ability to buy a ticket, and then you buy it and update a bundle.
correct. Gotcha. Thank you so much. Um, I don't think I have like any pressing questions. I guess the last one would be what happens. So I can see there's like a countdown going down, which is 39 minutes. What happens when it reaches 0? Is a new round started automatically, or does someone or like a process need to initiate a new round? How does that work?
New round will start automatically, and once a new round has started, in previous round, the winning ticket generation process is started. So first of all, in background, a reduced proof is generated. Then random is requested to generate the winning ticket in the previous round. But this process works in background, and while it's executed, players can play in the new round.
Cool. Cool. Thank you. It looks like really amazing. I'm like very excited to see this go to mainnet. So thank you for like all the work you've done over the last couple of months. Carol, do you have any questions for the team?
Sure, yeah. I just wanted to ask, great presentation so far, I guess that's great. But I wanted to ask a bit more regarding the transaction reordering and what's kind of the design goal there, and what are the bits that you're still missing to get that done.
Yeah, we wanted to implement some kind of transactions queue on backend. So people sign the transactions, and these signed transactions are collected on backend, and then they are executed one by one in background, because we can't put several claim transactions in one block. So we aggregate them off chain, and then they executed one by one on backend.
I see. So currently, if I understand correctly, there's only one claim per block that you have
the only way to overcome this is reducer, but we can't use reducer with nullifier. We need nullifier for claiming. So we need to implement transaction reordering to make several claims.
So you're still using one claim per block, though, right? That
Yeah.
would be still the speed.
Yeah.
Okay. I see. Cool. Yeah, I think that's it from me.
Oh, we got the transaction executed, and now we can see the new ticket here.
Oh, I see. Yeah.
Really
And
cool
then-
artwork. Yeah. Sorry.
Yeah, I can see the wallet balance went up as well for the claim, so I guess it was included as well. Oh, perfect.
Thanks for the opportunity to build such an applications, and we really like building on Mina. It's a very hard and interesting process to use cryptography in things in Ethereum that works automatically, but here we bring a lot of cryptography and build it together to make the service work.
All right. Thank you very much for the efforts you and the team have put in. I don't have any more questions. So thank you very much for doing the presentation. And yeah, good luck with launching on testnet and on mainnet. Thank you all for joining.
Thank you very much, guys.
Thank
Thank you. Bye.
you.
Bye.